while exploratory factor analysis is exploratory of nature, that it's theory driven, it's a deductive approach. None of the items that fall together makes theoretical sense. So the EFA, in a sense, already tells us something about the theory. So this is the wonderful thing about statistics. And let me tell you guys, if you look at Prof at this stage, with her experience, if she's looking at examining a student, these things will just start to pop out, and the golden thread that's supposed to be in the write-up is starting to tell us something is wrong with the data.
Just with examiners of, well, when people request you to examine on PhD level when they know that you're an expert in the topic, so you can expect exactly the same, that your PhD will be examined by, well, one international one and people that really knows your topic. So there's no way that you can, on a master's level, it's general people, but it will be someone that really understands the topic. So then they will ask you questions immediately because it just does not make sense. So it's like the sixth sense developed after examining a number of PhD in a topic. So they will see it. They will just say, what? This doesn't make sense. And as soon as they say that doesn't make sense, then you are in trouble.
Yeah, I had a PhD student from Kenya that she had to get special permission. She spent more than a year to redo her research after it was examined, and only got her PhD end of last year. We had to redo all the analysis, so it was like starting over, because as soon as I started poking in the data, none of the things made sense, and it took her a year to just redo that. So I think in your case you are safe. Everything looks according as how it should be. It's now about your write-up. All right, guys, EFA. So it's important. I'm saying here a very important thing. It's about scale.
Part of the data analysis is EFA. I love it.
Yeah. So what we do here is we're bringing in EFA. Now, this is a statistical approach, and I've had one of my students come back. Not all of my students have the privilege of 450, N of 450. Some of them have got very small data sets. I'm sitting with one for 290. So it means that this is not always being done, but in your case, Wanga, you had 450. So what the statistical approach tells us is to say, but if you've got a big sample, go back and split the sample. So remember, we're moving from an EFA where we want to kind of confirm, so it's not exploratory per se. We're using the technique in a sense to confirm the measurement structure. What does that measurement structure mean? It means that my questionnaire should be able to distinguish from an exploratory perspective between these constructs. So exactly so if I use a confirmatory factor analysis, these items should hang together. And when I say hang together, I mean that the underlying correlation between them should be stronger than, for instance, when I looked at the correlation between this item and this batch of items. So purely just from a free flow perspective, I want these constructs to emerge. But what is the approach that we do? So common method bias tells us that there's an issue. So that if we've got a questionnaire and we ask our respondents questions about our independent variables, we see inflation in the correlation when they are also asked to answer questions about our dependent variable. Do you see the problem? So we are inflating bias.
Just explain that again slowly. I couldn't understand what you're saying, the last sentence.
Okay. Let's just go back. The words that I'm using is common method bias. What does common method bias mean? Common method bias says, because of our methods that we are using, there might be bias that creeps in our measurement. So the fact that we have used a questionnaire where we ask one respondent on a scale and a Likert scale of 1 to 7 and items to tell them their perceptions about issues related that we have defined as independent variables. And we are also asking them in the same questionnaire about items that reflect on dependent variable. The fact that these things are correlated and this is correlated is inflated by a common method that we are using.
Which is the Likert scale on 7.
And it's the same questions that we ask for. So remember, there's a relatedness. The same respondent that answered about things on the left-hand side also gave his opinion about the right-hand side.
Now I get it. And that's why you split it. Okay.
So there's a common method. And in your write-up, later on, Zwanga, I gave you some articles about common method bias. This article by Brannick is a very important that you need to read, all of you. It says, what is method variance? Can you see it talks about method creating variance and how can we cope with it? And it comes from people like Specter, and it just addresses, some people say, don't worry about it. Acknowledge it, but you don't necessarily need to do something about it, because remember, the way that you have constructed your survey as a strategy and your questionnaire is part and parcel of how you collected your data. Some say, no, you need to collect data on your independent variable, and then you need to ask other people or a different method on your dependent variable. Now, that's very difficult. We can't have two groups, and how are you correlating? So, statistically, there's issues. But read this, it's a very important aspect that's becoming more important because of some people driving it in journals. I've had 1 or 2 or 3 journals that's coming back through my, especially in the industrial psychology and in human resources. So it's these pockets of journals and certain topics where someone has got this buzzword of common method bias. How are you addressing it? And we just need to be prepared to address it. So what does it say? It says, how can we counter for it? Now, one way of doing this assessment or this common method variance is to say, but if we look at our EFA, let's use a certain sample for our exploratory factor analysis, and then use another sample, a holdout sample or a confirmatory sample, when we then use confirmatory factor analysis. So it's all of these kind of creative ways of now dealing with validity and also the common bias that is created. Now, what is the bias that's created? If we would have used the same sample for EFA and the same sample for confirmatory factor analysis, we're taking whatever error we've seen in the EFA over to what we do in the confirmatory factor analysis. So by now making it 2 independent samples, it is as if you've almost done a longitudinal approach to your research. Does it make sense? So you collected data, you did your EFA, and then to confirm, you collected another set of data. So you're almost creatively doing something that is confirming reliability. Because what does reliability say? It says that I get the same measurements if I take repetitive samples. And we sometimes do this, is we split our sample into 2 random groups, and the one we do a certain analysis, and on the other one we do another example. I'm doing it now for another student.
Can you do it on SPS to tell it to split it randomly or what?
All that I do, there's a function, data, transform.
I saw split.
Select cases.
Yes.
And it says a random sample. And I say, and I've calculated. Okay, so let's just quickly go back. Sure. Why did I select 165? Yeah. So let's just quickly go back. Scale assessment is very important because it's not confirmation yet, and even if we use confirmatory factor analysis, we never really confirm. Guys, statistics is a wonderful field, but sometimes we use these words and we are being led by the technique, exploratory factor analysis, confirmatory factor analysis, and we think that those techniques only apply to exploring and only apply to confirmatory. Some of the articles will tell that yes, but it's not in that sense. This is the same. We're assessing the scales. Do we see that these items hang together so that we can make the argument that whatever value we get at the back of our data set, the observed value, that it can serve as a valid and a reliable proxy for the construct that we are measuring. That's only statistically. There's another element, or your validity. The fact that you have asked your supervisor to review the questionnaire, the expert reviews, if you've sent it to people in the marketing or in the social media or whoever, those are all expert opinions. And experts' opinions are very important because they make judgment about your measurements. So you can't just argue it statistically. This is what I say here. First, it's about theory. Your supervisor has got the hat on as a theorist, as someone that is looking at it from a theoretical perspective, and they make a judgment to say, yes, these items can measure this construct. Not about statistics, it's about judgment, expert judgment, not face value. Remember, this thing about face validity is it's an issue, because what constitutes someone to give face validity? Can you ask the person that's selling flowers next to the road and say, on face validity, do you think this constitutes a reasonable scale? They've got no background, rather argue it from an expert opinion. And secondly, it's about the statistics. So sometimes we can override what the statistical evidence is telling us in favor of what the theory is telling us. So now the question is, what is a validation sample? This is coming from Hare. Guys, you know this textbook by Hare? You know this textbook? Multivariate data analysis. I will send it to all of you again. It's the latest version, the most recent one, so it's up to date. But it tells us about why do we do this? And your argument for doing this will come from Hare, your reference. It says, a validation sample is a portion of the sample held out from estimation and then used for an independent assessment of model fit on data that was not used in estimation. The split sample validation says it's the simplest form of validation where the sample is divided into two subsamples, one used for estimation, this is what we've got for the EFA, and the other for validation. This is what we will use for confirmatory factor analysis. So I've split it into a sample size of 165 for your EFA and 285 for your confirmatory factor analysis. Now, who said 165? How did I come up with this number? You must argue that as well in your write-up. You can't just say, oh, I took a sample of 165. The examiner will say, but how did you come up with that number? Then you go to this part and you say, Hare also states, regarding the sample size question, there are guidelines based on the absolute size of a data set, the ratio of cases to variables. Because remember, we're talking about exploratory factor analysis and the strength of the factor. In terms of absolute size, researchers generally would not factor analyze a sample fewer than 50 observations. We've got 165. And preferably the sample size should be 100 or larger. We've satisfied that, but now it comes. The general rule is to have a minimum of 5 times as many observations as the number of variables to be analyzed. We've got 33 items multiplied by 5 cases for the ratio, which gives us 165. And it leaves us with 285 for the confirmatory factor analysis, which is also sufficient if you go to Hare. Can you see how you are arguing constantly your rigor of your design?
Dion, this 5 sample size, does it apply to, do you only write it that it applies to EFA, and then
yeah, that's typically
do the rest if it's big enough for CFA?
Yeah. And then whatever is left, we must also make sure that that 285 is reasonable. And 285 and confirmatory factor analysis, the way that we are approaching it, that 285 is more than enough. And even if we go on and we use regression analysis or whatever we use thereafter, group differences, we also satisfy all those sampling. And that Zwanga or whoever just needs to go back to hair and just find those texts in hair, just to say that this is typically, the minimum sample sizes that we need. It's easy. We just go to past research, and if we find past research where they, for instance, use 280 or 250 or 300 for confirmatory factor analysis, we can just say it's in line with past research where they've used a similar sample size. So when we get there to the write-up, we will address it. So from all aspects, we can satisfy the requirements as proposed or recommended by the scientific community. And we've got, so that part is solid. We don't have a problem. So all of this, the whole approach that we are following is according to the scientific community recommendations. All right. And this is your EFA. So now we've got a sample, and you will see if I go to your, here I've got a separate data set to say 165. So I've used a sample in EFA, and like I said, here I said 165 from your 450, and I got a random sample of those, and the rest was saved for my CFA. Does it make sense from a process perspective how we've addressed it?
Yes, thank you. It's very interesting.
And I think what is important, Zwanga, and whoever is writing it up, you need to mention that this is a preferred recommended approach to doing your analysis. So make a fuss about it. You need to emphasize how your research is better than other research. Otherwise, you lose the opportunity.
This time I've read about the split, and then I understood it. But is it the first time that we applied for students? So it is noteworthy in my mind.
Yeah, it's again, it's almost how the wind blows. I've got here examples of articles where the guy has not used it, and he argued in case of not using it. So
usually all I've seen, I've never used it. So all the articles, I've never seen it. But I think in terms, especially because Zwanga, you have 2 malls, so I think that is just again you just tell that no, you can use the data.
So it is really about I want to say, but someone might say, so if I could have also made the argument to say it was not necessary to use it. I had one student now that finalized his PhD. Feedback from the examiners were, it would have been beneficial, or you could have considered splitting your sample, but it's not a given. It's not, it must be done. So, and then they can just say, yes, to consider, it was considered, but these are the reasons why we haven't done it, mainly because of sample size restrictions or whatever the case might be. Or past research students didn't do it, So there's many ways to kill a cat, but I think in your case, the benefits are there. So
Dr.
let's argue. Yes?
In terms of this data, when it does this random sample, so the operation part of it, do you know if it just picks up 165 randomly, and then it will put them aside, or when you're gonna do for confirmatory, still gonna have respondents have a chance to be picked up again? Because is it splitting, or it's just random sample?
No. So what I did is I selected 165 from the 450. Yes. So let me quickly show you. Here's an option: filter out unselected cases or delete unselected cases.
Okay. So that it can be split. Yes.
Yeah. So now I've got at the back, I've got this. And here I then say 0 is for my CFA and 1 is for my EFA. And I can now create 2 data sets. So I can quickly sort this. Yeah. So operationally, I can now delete these cases, or save the data set.
And use them for EFA. Yes.
So whatever is
Paul and Zwanga, what Sufisho just asked is, if you split it in 2, he just wanted to make sure that he has an one part for EFA and one part for CFA, because if you do that process again and not the way Dion explained it, you might get duplication of the.
Yes, we understand.
So what we need to make sure is that whoever is in the EFA sample is not in the CFA sample. So they are two distinct independent groups, sample groups. Theoretically, because you've taken a random sample, a pure random sample, from a population perspective, they should match. They should be the same. Profile size, all of those, but you don't need to argue it. It's a random sample. Because remember, a random sample, if you take a random sample, they are the same. So this is just the process. So I've got two data sets, one with 165, one with 285, and whoever is in here is not in here. But later on, after I've confirmed everything, I pull them together. So for group differences and path analysis and all those things, I'm still working back to the 450. Does it make sense, guys?
Yeah, it
Only
makes sense.
for the EFA. Yeah.
It makes sense because it also helps us, you know, with the writing, you know, when we start using the word split and use the word random, we already have the operational part of it. We know that it's actually split rather than it's just random and another random.
And I think what Sophia is trying to get at is don't get lost in the detail, but the process that Dion is taking you through, it does not matter whose data it is. That's exactly the same process. Remember, when you research methodology, you have a certain process that you follow, just apply it differently. So this is exactly, it doesn't matter whose data it is, you'll follow the same process if possible, if you have a large, so when you do EFA and CFA and we have a large enough sample based on that, you can either do it together if your sample's not big enough, because that's customary. That's the first time which I actually see it, but ideally if you can split it, you can split it. But Dion, then once you do the SEM, you put it together again. You use the whole sample, is that correct?
Yeah, so after my, so here I do my 285 for my CFA, and when I go back to my group differences or construct descriptives, I'm back to my 450. Okay. So I've shown whatever, so I've explored, I validated, and because of the validation, I say, guys, we can now pull everything together. So now I'm back to my very stable big sample size of 450. I've got this student with a data analysis plan. So exactly a similar approach. So I've got the sample profile for the measurement part for the EFA. I've got 200, which I've done. Now for the CFA, I've got the complement of 478. Then I go back. So in her case, it's even more complicated. So she's doing a logistic regression. So for logistic regression, I'm taking another sample. So then there's another model building exercise. Now I'm taking a random sample again, but I use another random generator. So I'm actually going through this process twice. And all that she needs to do is she just needs to argue we do this to improve the process of exploration to estimation or validation. So it doesn't matter how we go about, it's the argument that we are making. All right. But it's very important, it's nitty-gritty. But remember, you are selling your research to the examiners. That's the difference between coming back and having lots of questions about your research, or that they say, well done, we've accepted as it is, now there's just a couple of critiques. You could have considered this, or you might have thought about this, and then it's easy to address. Thank you very much. It could have been considered, but we stick to our data analysis plan. So most of my students in the past, from UNISA, where we have used whatever approach, and they've made sure that they write it up to the nitty-gritty, gets very little feedback. So there's a lot of attention that goes into the write-up. All right, let's get back to the EFA. The EFA is now a matter of what are we looking for. For me, it's important that when you discuss EFA, it's not just that you say, oh, an EFA was done. That's not the reason. Explain why we considered an EFA. The reason being that we've got these constructs, we want to assess from an exploratory factor analysis if we can confirm that these constructs emerge from our data.
What Dion said is very important because it shows that it shows that you understand how the theory relates with the stats. So it's very, very important.
Now exactly that. Don't let the examiner hang and say, but why did this person then consider an EFA? I mean, tell them the reason. An EFA, and go back to Hare. Hare tells us in the initial chapters, why do we do exploratory factor and cite, reference that, and not just Hare, any text. You say, we consider doing an EFA to confirm or to support what we are calling what's coming from the theory. And this is what I'm coming back to, is the difference between the measurement model and the structural model. So I want to introduce these two concepts now. What we are doing now is related to the measurement model of our research. It means that we are looking at this, but not in terms of the roles that it comprises. We are looking at it from a perspective of merely trying to confirm or identify that this construct emerges from our data. Now, luckily we're recording it. So an EFA tries to find a pattern of where the correlation between the items are greater for certain items than for others. So it's looking to identify the emerging hypothetical constructs. So we are trying to look at the items that hang together, irrespective of the role that they play in the model that we are proposing. So it's not about that this is a dependent variable and this is an independent. We basically put them all next to one another and purely assess them from a measurement model. So this can be a dependent variable, but we are looking at their co-correlation. We haven't assigned any role to them yet. And this is the important of where we are moving towards. So I'm almost going to jump the gun and show you what is the model that we have tried to assess from a CFA. Can you see I did not put whatever is the dependent variable on this side. I'm not in a, where's mine? I'm not yet in a format where I'm trying to predict and assign rules to them. So I'm not in the structural model part. So this is a structural model because now I've assigned roles to them. I've started moving the things on the left-hand side to say, but this one must predict this one. All right, team, you must understand the difference between what is a measurement model part of it and what is a structural part. So in this part here, that's a measurement part. But as soon as I start applying roles to them, to say, but positive affection is related to utilitarian value, which helps predict satisfaction. I'm in a path or a structural model perspective. We are only now considering the constructs, and this is where the EFA comes in. So I'm trying to look at, do these emerge from my data? So there's a couple of points where I stop. So the first is your sample adequacy. Is there evidence in the data to support EFA? This is basically what I'm busy with. And the first stop is to look at the KMO sampling adequacy. What it's trying to assess, is there evidence in the correlations between the items to say you can carry on with the exploratory factor analysis. Now, if you go to any textbook, this is an index, and it says anything above 0.7 is great, anything above 0.8, and they give like a name to it. We consider a 0.8 as the minimum or a 0.7, so this already tells us there's evidence in the data to support that we can do an EFA. It doesn't say that we will find that we are looking for, it merely tells us that the data has got variation, there's correlation between the item. Can you see how it ties back to when we did the item analysis, where we looked for these kurtosis? If we find that some of these items show no variation, it will tell us here It will say, but there's no variation, no correlation between the items. So it doesn't, you don't even try to attempt an EFA. The next part is your Bartlett's test of sphericity. And this is a hypothesis test. So it says your null hypothesis says that your matrix is an identity matrix. Identity. What's an identity matrix? So a correlation matrix, this is a matrix. Can you see that all these diagonals are equal to 1? What does this mean? It says that there's a perfect correlation between this item and itself. So if I duplicated this item in my database and I correlate it, I will get a correlation of 1. But now I'm looking at the off diagonals, and I'm asking myself, does these constitute significant correlations? And I can actually go down here and I can say, yes, these p-values are all less than 0.05. So it tells me that this is a significant positive correlation between this item and this item. So it means that if someone disagreed with this item, there's a very good chance that he will also strongly disagree with this item. So all of these items, I look at it here, their correlations seems to be fairly significant. In fact, the average correlation is 0.59. So it seems like all of these items that's got to do with CI hang together. But more than, for instance, that when I look at CI1 with ENT, and that makes sense. I don't want this item to be that highly associated with another construct that it's got nothing to do with. This is what we call discriminant validity. So on the one side, I've got convergent validity. They converge, they are highly interconnected, but with other items, they are less connected. It means that they can discriminate against one another. And this is what I'm looking for in my EFA. So this tells me that no, my matrix is not the identity matrix. It means that these off diagonals are not equal to 0. There's actually significant correlations which will allow me to do EFA. Now, you will find in a textbook like Palant or many of past researchers where they address a simple write of one paragraph where you report this. But it's not just reporting the statistics, it's making the conclusions to say, but we can carry on with EFA.
Sorry, John.
Yeah.
I will have to go now. I had an hour, 30 minutes. I'll check out the recording. And then, yeah, we'll continue the conversation.
All right. Good luck, team. Are the rest of you still willing to continue, or do you want to reschedule another session? I think I'm on a roll, so it's up to you.
I think, Dion, let's do the EFA and at least till 10 o'clock, and then we can reschedule another session, because Pauline can watch it, but just to stop in the middle is a bit, we're curious.
It makes sense because I've got another meeting at 10 as well.
But I'll record.
Okay.
Yeah.
Bye, Pauline.
Bye, Sfiso. Bye, Zwanga. Bye.
Zwanga, are you still fine to continue?
Yes, right. I can continue.
I think somebody responded for her. Bye, John. Thank you again.